Good morning, everyone. Today is the 9th of October. Just a quick recap from last week. But before I go there, I think all of you received an email from me. I hope all of you received an email from me, and I am trying to work backwards and kind of collect the emails that I sent and the projects that I assigned to you, because it was like some random. I have a database of projects, and I'm randomly assigning it to each one of you. So you can see I'm also, it's all a script that is actually doing all the work. So after this class, maybe later today, I hope to send you the solution for the project, so you can actually have a look at how it is being solved. All right. So like that, I may send another assignment before assignment on top of what is in the lesson. Okay, these are, I call this simple projects that you can do. It's like creating a game, playing around with arrays, strings and stuff like that. So some of you have tried, and some of you have asked some questions, and in terms of not understanding the project and so on and so forth. But let's keep the interactivity going. Yeah. And Loga, you have raised your hand. Is there a question you have? No? Okay. Let me just come back to the window. All right. Okay. So so that's the idea of the projects, and don't stress. Okay. Even if you didn't do it, it's fine. Just have a look at the solution and how they actually coded it, so that you get an idea of how to do the simple example. So in the real world, it's going to be a very textual based question. That means they're going to describe it in a lot of words. All right. So you need to be proficient enough to read the context of the problem, the project, or how they describe it. So I can show you the kind of mails that I've been sending. And yeah, so some assignments have come in. Basically, okay, for example, I will have a title for the project. Okay, and you must write it within 10 lines of code. So you need to write very compact statements. All right. And then there will be some description of the task. All right. And then I will give a description of the project. Okay. It is also a very good way of learning learning computer science, because there are a lot of algorithms. All right. There are a lot of ways to search a list of characters, or search a sort. There are many types of algorithms for you to play with. All right. So this is a very, very subtle introduction to various types of searching methods. For example, in this one, you will learn a binary search tree. That means how to use a binary search tree to actually search entire document and find certain things inside it. Okay, so it's got some description, and it's also a good starting point. If you don't understand, you can actually search the web. All right, and I got this all from the web. So it is sitting somewhere in the web. And then once you have done once the week is over, I will actually send you a solution. All right. So for example, this is a test. There will be a solution. You can just click on the solution, and you can actually see the code, how it's written. All right. So this is what I will be sharing with you. All right. So for all the stuff, even if you don't do it the first time, never mind. Keep trying. Just keep looking at the code. As you read more code, you will start to figure out how actually it works. Okay, so that's why early introduction is good, especially people like me who learn very slowly, need a lot of help to get started. So I get started early on, so hopefully some point we will reach a point where we understand. Okay, so that is about the project assignments. Okay, and then you have assignments within the lesson itself. So coming back to last week's lesson, we talked about squares, roots, and cubes. Now, the takeaway from this class is this lesson is that we need to look at the entire number system as one big number system. We can't look at it in simple parts. The same way, when you look at your data set, when you look at data, you need to look at the data in one big number system. All right, it's one big, let's say, bracket or kurungan, one big kurungan. So whatever we do onto the data set must apply to every element inside the data set. That is the most important concept you have to understand. We are not going to go inside the data set and pick one value and then do something else for another value. No, we have to apply. Let's say you have an image and you want to blur the image. So the blurring will happen on the entire image. That means we don't select certain pockets. Okay. Of course, if you want to, you can, but you must think that now whatever we do is going to apply onto the entire number set. Okay. So that is why I wanted you to see the patterns in terms of how the numbers actually repeat themselves. When we do multiplication, it's a pattern that we apply onto the number system. It's applicable to the entire number system. All right. So we can see how squares have a repetitive pattern to it, how cubes has got a repetitive pattern to it. And then what I want you to know is that you need to recognize this pattern from a visual perspective. That means this is x squared, this is x squared, and x cubed, and x to the power 4. So you can see that the gradients all get more complex with the power, polynomial power. That's what the power is actually called a nomial. So poly means multiple, all right, multinomial. And this is a very, very simple assignment for you to plot. So I just want to introduce the plotting function to you here, because once we handle data in the next class, once we handle data sets, you'll be doing a lot of plotting and all those other stuff. So I have some interesting stuff for you all to do in the next class, which is data handling. In data handling, you'll become a little bit of a statistician. Okay, I will bring in things like standard deviation and all that stuff. So that's why I am slowly taking you all through this process of learning how to plot it. Okay, so that is a recap of the third lesson. Okay, so now we're going to go to the fourth lesson. So I would like all of you to go to the website. Where is it? It's the GitHub location. And I think I uploaded the recent file, 25 minutes ago. So you can click on this link. All right, I will just share the link to those who may not have it. Oh, nice. We've got a lot of participants today. Yes, Kalimahal, we will organize the second and third video. I think probably my email engine didn't recognize your name, so I will try to make sure we get that sorted out. All right. So this is the link. All right. So let's get started with lesson number 4. Now, since you know that we are going to do we need to download any other program? Okay, that's the beauty. You can see that in lesson 3, we didn't have to download any program. You just have to do import matplot library here. All right, this will enable you to plot. So you don't have to download any software. It's all built into Python. Okay, and thank you to MATLAB. MATLAB is the one that actually provided this library called matplot library, and we are calling a particular function, a method called pyplot, and then we are giving it a handle, a nickname, like a pet name, plot, PLT. So wherever in our program we just call PLT, it will point back to matplot library, pyplot. Okay. And then we just do plot, give it the X and the X and the X, it will draw it for us. So you can see this is the base X, the 0, 1, 2, 3, 4, 5. And then this is the X squared, X cubed, and X4. So after the Y value, which is the power of X, we are giving it an indicator how to draw the plot. So we are saying B is actually box, S is actually, sorry, B is actually blue and S is actually square. So that's why you got blue squares. And then you got green triangle. And then you got red dashes. All right. So these are all standard stuff that is already inside the pyplot. Okay. So you can easily plot, and we're going to do some plotting today. So that's why I wanted to introduce that in lesson number 3. So in lesson number 4, again, don't worry about downloading any software. We all have it here in Google Colab. All right. So let's begin. First, you need to understand that we are going to handle everything as a matrix, because we are going to handle it as one number system. All right. So if you have a problem, the data that you get for that problem is one big data set. We are not going to pick it and say this is that and this is this. No, we're going to take it as a one big matrix and apply a filter on top of it. A filter is like a multiplication. All right. In matrices, you only can do multiplication. You can't do divide. Okay. Remember that. So we have certain things later. When you get more advanced, you have like inverse matrix, you have the identity matrix and all of that, but we don't want to get into that. Okay, we just want to do a simple equation. Okay, equation where y equals to 2x plus 5, okay, is one equation, and then another equation is y minus 3x plus 4. I know that all of you can solve it using pen and paper, but today we're going to use a Python program to solve this problem. Now, why we need to solve this problem is we need to understand what is what do we mean by solving it? What does it mean? What is the result of actually solving an equation like this? What does it mean? Okay, we're going to look at that. And then once you understand this, then you can easily expand it to any power. You can go to power of 100,000, 200,000, no problem. We're not talking about power of 1 or power of 2 or power of 3. We're talking about the entire number system. So you need to have that expansion in your mind, that you're not looking at just one particular area of the number system. You're looking at the entire area of number system. And it can go from X, Y, Z, A, D, B, C, whatever. It can have multiple variables. All right. Like how you want to solve a problem. If a car doesn't start in the morning, you got 20,000 things that can go wrong inside a car, correct? So we create 20,000 variables. A variable is X. X is an example of a variable. So you can have X1, X2 until X 20,000. So you can see X 20,000 human beings cannot solve with paper and pen anymore. That's why we need Python. So Python will try to help you solve what actually caused the car to fail, because we can handle 20,000 variables all in one equation. All right. So if you have 20,000 equations, then you need enough variables to actually so you can actually solve any problem. That's where I'm slowly getting you all to. Now, how do we solve this? Is by applying linear algebra to it. Okay, so you can see what I have done is I have written that same equation in this particular format, where the y and x is on the left hand side and the constant value is on the right hand side. So you can see that this equation and this equation is actually the same equation. It's just that it's represented in a different way. All right. So you can see that what I did was I took the 2x and I put it this side of the equal sign. That means it becomes y negative 2x plus equal to 5. That's all I did. Okay. So I changed it, and don't be confused. This is actually, we are not changing the equation. The equation is still the same, right? We're just representing it in a different way so that we can now equate the other equation also the same way. That means they must have this order of the y first and then the x. Okay, so you can see that we can actually convert this into a matrix. All right, now, so once we convert this into a matrix, right, we can easily solve this using Python. So it doesn't matter. So this matrix here can be 20,000 variables, can be 20,000 rows and 20,000 columns. All right. Okay, it can be 20,000 rows and 20,000 columns. Now, we don't have to go through this entire process of calculating it by paper anymore. We can actually use another library called Numpy. Okay, and we can just put it in as an array. So please pay attention to the syntax here. So you can actually write, see, this is the pet name for NumPy and NP. You can call it anything you want. You can call it Puchi, Kuchi, whatever you like. And then you can say np.array. We are calling the array. And when you mouse over it, it will actually tell you what it is. So it's an array building function. Okay, it builds an array. So you can see I've created an array, but you must understand it is an array inside an array. So that means it's a two-dimensional array. So you got two brackets here, square brackets, but there's only one square bracket. That means this is one array, one row column, and then one row column, and they all come into one big array. All right. And then I have actually created this array here. This array here is A. Okay. And I've left out X and Y and X. And then I've created array B. Array B is just a standard. Always look at the number of rows first, row, column. Okay. Row, column. So it's 2 rows, 1 column. All right. That's how we look at the shape or the dimension of the array. Okay. Row, column. Remember that. So once you can, all you need to do is call this method called linear algebra dot solve AB, and it'll give you the solution. I need a ovation right now. See how easy it is. No need to go crack your head and find out what is the solution and all of that, but we can go on to test it out. Okay, it says that. So again here, all right, you must remember that it never said what is y and what is x and which is x and which is y. So you come back to how you defined it. So you put the y in front, so therefore the first value is y. All right, so it will follow this order. So if I change these lines the other way around and put x on top and y down, the answer will be different. So it's important to understand what is happening here, because then only you can interpret the result. Okay, so even if it's a 20,000 equation matrix with rows and columns, you still need to know which one is A, B, C, or X1, X2, X3, so that when the result comes out, you know how to interpret the result. Make sense? There will be certain quiet spots where I will allow you to ask questions, like right now. If anybody has got a question, you can ask it. This is important for you to understand machine learning, because in machine learning, all right, everything is handled as a matrix. I'm not joking. Okay, so you must understand that this is a scalar. That means it's 1 by 1. That means it's only got a value. And this is called a vector. So a vector can have a row and column. So the row is the first value and the column is the last value, second value. So you have m from, it's going from 1 to m. So that means this is the m number of rows and 1 is the column. So m number of rows and n 1 column. So this is the other way of expressing it. So you can see that x1, x2, x3 can just go until n. N can be any number, 20,000, 100,000, 150,000, we don't care. All right, but it can be represented as a vector. So we take the entire data set, all right, and we dump it into like a matrix. So a matrix can go this way and this way, you know, so it's got two, so you see that a vector is always by 1. Whether it's either one of the, whether the row is 1 or column is 1 is considered as a vector. If the row and column is more than 1, then it's called a matrix. Okay, and then there's another one that is called a tensor. All right, a tensor is third dimension. That means there are multiple matrices inside one tensor. All right, so the tensor has got depth. Position of x and y, how is it determined? Yeah, so it's determined by how we write the equation. You can see that I have put 1 minus 2 as the first array, okay, and then because 1 is actually representing y and 1 is representing in this line, it's also representing y, because when you look at the equation, both of the y's are coefficient, the multiplier to the y is 1. So that's why it's 1, -2, 1, -3. So it's 1, -2, 1, -3, right? So when I do the matrix calculation, right, it should give me back the same equation. So if I take 1 and multiply by y, I will get y, -3x times x, I will get -3x, and then the 4. All right, so I have stacked it up this way. That's why the first element is y, the second element is x. That's how we determine the answer here. The first element is y, the second element is x. Exactly. Now you understand why algebra is made so simple, because we can use matrices. All right, so we are going to apply onto the entire data set. Okay, so for those who forgot how to do it in, who didn't understand how to do it in school, you can actually, this is from my data science class. Okay, so we actually go back to this. I'm teaching engineers this stuff, so it's sometimes it's a bit shameful, but it's normal. So you can see the first value is actually 1 times, so it's the row times column. So row times column. So 1 times 4, 2 times 5 plus 3 times 6. and then I get a final answer of 32. Why? Because of the shape. So when we multiply it with a particular column, we are changing the shape. The outside shape takes over. So, and in order for a matrix to happen, it must match the number, this number must match. All right. So this is the fundamental rule for doing a dot product between two matrices. Okay, so it doesn't matter whether it's a tensor, or it doesn't matter whether it's a matrices or vector or whatever, they all have to have this match in terms of doing matrices. So just to, so if it gets a bit more complex, like this is a matrix, so the same thing applies. All right, the same thing applies, and you get your final answer. All right, so you can see again the match should happen in order for you to get another result. So usually it's always this one that monopolized. So you can see what we are doing is it's a 3 by 3, but now we brought it to a 3 by 2 by multiplying it with a matrix that's 3 by 2. So that means we can apply a filter and filter the data set and get another data set that is almost that is the same shape of the filter in the first place. This is a very important concept. Okay, so we can manipulate a lot of matrices this way. So I don't know whether you remember this, but it's just a little bit of a refresher. Okay, so then it starts to get more and more complex. You can transpose, you can find the inverse of the matrix, and a lot of things that will start happening. All right, so this is just a basic introduction to linear algebra. So now linear algebra is you can already solve anything. Now you just have to know how to present it in a certain way where the matrix is legible, the matrix is conforming to the requirements of it being a matrix, and this concept of applying filters is what we actually do in data science to extract information, I think there was a question, somebody actually said that they tried to use pandas and then they failed, they couldn't do. The reason is you must think as pandas applying it to the entire data set. Okay, when you think that pandas is going to look at one element and then the next element and then the next element, you will fail. Everything you do with pandas is actually a matrix operation onto the data set. Okay, so remember that. If you don't understand, ask me, I'll try to give you more explanation. So here I have tried to prove what I found. So if x is 1, I will get 7, and if y is 7, I will get x is 1. So it's quite easily proven to be correct. Okay, so that is the idea behind finding a solution. So now I've done the same thing to prove x. Okay, you can try it out to prove it to yourself. So now you know how to do linear algebra. You know how to solve. You just type np dot lin means linear, linear algo, or it can stand for algorithm, but I prefer to look at it as algebra, linear algebra dot solve. Okay, it's that simple. You can get the solution, and if it's 20,000, you'll get an array of 20,000 values if there is a solution. Okay, sometimes we can find that there is no solution. All right, I will get to that slowly. So no questions so far. We will go on to plotting. We want to plot these two lines. Okay, so let's plot it. Don't worry about all this code. Okay, we will come back to this later, but basically what we have done is we have drawn the two lines. Okay, we have drawn the two lines, and the value of 1, 7, or maybe I should put 7, 1, but usually whenever we talk about coordinates, we always specify the x first and then the y. So at 0.17, you see I've done this with Python. If you look at the code above here, it's actually putting the title, okay, which is the solution for both equations. I'm setting a label for x, so it's not showing x. Yeah, it's showing x here, and then I'm creating a vertical line. a vertical line where x equal to 0. So this is the x equal to 0 line. Then I am creating a label for y, which is right here. Then we are creating a horizontal line where y equals to 0 right here. And then we are annotating. Annotate means to draw this particular thing, this particular thing. All right. I need to say annotate. Annotation is a way of describing points on a particular graph or on a particular plot. Okay. So it's very simple. All right. Don't worry too much about the code right now. But what it's doing is the first value is actually what you want to plot. Okay, so you can see that I want to plot x comma y. This x comma y is actually this x comma y equal here. Then I have the brackets, and inside the brackets I have a percent sign dot. That means there is a value that needs to be put here with 1 decimal place, and f means it's a floating point. That means it's a decimal number. All right, and there are 2 decimal numbers, and I end the string. Okay, and then I will say percent represent x data with this value and replace this percent with y data and put the formatting as 1 decimal place. That's all I have done. Okay, so this one line will draw this text here. Okay, we take it step at a time, one step at a time. Then where do I want to draw it? That's when I give it the xy coordinates. That means the y data and x data. That means it's in this, x is 1 and y is 7. So I need to give it the second one is, so we first one is what to write, where to write it, and then we have an offset of, because I want to offset it. I don't want to put it on top of I don't want the text to appear right here. All right, that's all you need to do. And then all this is all very what is that? You can put the box style. What sort of box style? You can see the box is a rounded curve, and then you can do arrow props. Arrow props is a variable that I created here. I want to use arrow, connection, angle. These are all you can just copy, but I would suggest that you slowly tweak it, and you will find that this line will change. You can draw a straight line like that. You can do it an angle. All these things, all you can control using these arrow props and bounding box. All right. So you can see that I have already given the values for x data, y data, which is the solution. Then I've given x values to go from negative to 5. So this is my x, and this is my equation. Then I just have to put in my equation into the plot. That means I give it the x value and my equation. Remember our equation? Yeah. So it is, so you have to rewrite the equation again here. So now the equation must be written y equals to, all right? So it is y equals to 2x plus 5, because remember it was negative 2x, all right? And it was negative 3x, but now it's positive, because this one gives me a direct relationship between x and y. Okay, so that's why we write it in this manner. So there are slight changes only to present the data. It's the same line. Okay, I'm not bluffing you. You can try it out for yourself. It will still be the same again. So then I give the plot commands. All right, and then I do plot show. All right, so that's how we get this graph. So what is the point 1 and 7 now? It's the intersection between the 2 lines. Okay, so if the 2 lines do not intersect, then there is no solution. Okay, there is no solution. So I would suggest that so now you can actually plot any graph and see where they intersect. So the linear algebraic solution or solving is to find the intersection of 2 points. That means where they meet. If something is varying this way and something is varying that way, we find where it intersects. So that is the basic idea of finding a solution. All right, I'm sure most of you would have known this already, but let's look at something more complex. All right, is this complex?
Not really.
Oh, great. But this is the real world. Okay. The real world, we have complex equations. Okay. Again, you can convert it into a matrix. All right. So you can see how I've stacked it. All right. And so I have the coefficients. Okay. It's 2 because from the 2 here, 1, -1, and -3, -1, and 2. So I've converted this to, so this one is, yeah. So this is just the coefficients. All right. So I have put X, Y, Z, and then I put the constants, the output. Okay. So the filter will be X, Y, Z. So this is the filter that I'm applying onto this matrix to get this result. So I'm trying to find out what will be the filter that can filter this matrix and generate a result of this type, which is how we do here. So we are converting. So again, we are doing the same thing, but now we have a matrix, not a vector. Now we have a matrix, and this matrix will then generate a solution. Okay, so the solution, you just have to run it. You will get X, Y, and Z, and then we can then plot it. All right. Again, now we are going into the third dimension. Okay, the third dimension is what we can visualize. Okay, the human mind is limited to only 3 dimensions. Some people can imagine in the 4th dimension, all right, but beyond that, it's very, very difficult to visualize already. So you just imagine I have 3 variables, and it's already at the edge of our imagination. So that's why we need things like Python to handle 20,000 variables. So we cannot imagine, we can't plot it. You know, it's highly impossible to plot a graph that is got 20,000 dimensions. All right. Dimension means like X, Y, Z. That's a dimension. Dimension means area, the degree of change. I mean, it can change in that dimension. So when we say 4th dimension, we are talking about time. So because there is time, you can see the space actually starts to move. You know, there was a previous space, and then there's present space, and there's a gap between that and all that stuff. All this is like time coming into as the 4th dimension. But beyond that, it's very difficult to imagine from a humanistic point of view. All right. But the world operates on a non-linear platform. That means everything is not a straight line. You know, like for example, the Earth is going around its own axis, and then you have the moon going around the Earth, and then you have the Earth going around the sun, and the sun is also because of the size of Jupiter, it's being dragged left to right because of the size of Jupiter. Jupiter is so big, so even the sun is oscillating, and we are oscillating around the sun. So it's like one big non-linear system happening right here. So that is the real world. That is the world we are in. So we need the maths to solve it, correct? So this is not a very, very advanced course, but it's just to give you the perspective of where we are going to go with this. All right. So I've taken the liberty to show you how to do an equation, solve an equation. Here we need to use another, what is that, library called SymPy, okay? And here I can write the equation as it is, all right? So I can write the equation as it is. That means x squared plus y squared equals to 5. And then 3x minus 5, which is the line here, 3x, because I brought it in as y minus 3x equals to 5. You have to put it in that description, 3x minus 5 equals to y, and then you can solve and get the point where they intersect, okay? So if you draw this long enough, you can see that this x squared, y squared is actually a circle, all right? And because it's a circle, all right, there will be two solutions to the problem, not one, because it is intersecting the circle in 2 points. All right, so this is a very simple example of handling non-linear equations. Okay, so now we know how to solve linear equations. All right, this is a linear equation solver. All right, now we know how to solve non-linear equations using SymPy, which is a bit more complicated library. So we don't have to go and work very hard and today asking our students to memorize the times table and all of that is actually not necessary, because they all walk around with the phone and they have a calculator there, and they can do scientific calculations just on their calculator. So the idea is now to be able to use it as a tool, all right, and to give it the data according to how you want it to solve that equation. All right, so this is this is for this class today. This is what I had prepared for you guys. I have a very simple basically you have an equation here that I would like you to plot, and hopefully there is a solution. Okay, and if you find the solution, maybe you can annotate it. You can copy the code that I have written right here, how to annotate a contour, and I would strongly suggest for you to kind of play around with these equations. All right, try to find some other equation that all you need to do is just change this this equation here. You can copy this code and then rewrite it. You can create a new equation, so you can see equation 1, equation 2, and see how it plots. Okay, so you can see that I've actually written the equations here as well. So I'm plotting it x, and this is my x value, and then my this is my y value. Okay, this is one plot, and then I have another plot that is happening here, which is the circular plot, which I'm using contour to draw. All right, so you can do the same thing. So this one is more for a linear line. This is more for a circle. All right, so maybe you can draw two circles in a ring and see whether they, you see, if it's like this, you'll never have a solution, right? So there can be situations when there is no solution, and there are situations when there is a solution. Okay, this goes into another branch of mathematics called discrete and probabilistic. Okay, so the probabilistic means probably the best answer. Okay, deterministic means okay, there's a solution, like here there is a actual point where it intersects, so that is very deterministic. I can actually say that there is a actual determinant that that intersects between these two lines. But if it doesn't, then we try to find probability. What is probability? Probably the closest point. Okay, so I want you to understand that in machine learning, we also have this problem. Sometimes there's no solution. Okay, there's no solution, but we try to find the most probable solution that is satisfying for our experiment. Okay, that is why when you do machine learning, we need to evaluate it. How good is your prediction? Because it's a probability basically at the end of the day. All right, there is no real solution, but it's not very far away from the truth. I think the statisticians will agree that statistics is way out. Okay, way out, but it gives us an answer of generally where it's going. All right, and in machine learning, it is all definitely wrong, but very close to the right answer. That is what machine learning is. So as it learns, it gets better, and with more data, the equation gets better and better. So now you can understand how we use matrices in machine learning to do our computing, to find a solution for the world, right? That's basically how we establish the mathematics. So what I want to tell you is that the mathematics is real. Okay, it's real mathematics, not some mumbo jumbo. Oh, there's a prediction happening. No. It's all very mathematically driven, and it's very basic mathematics that we've studied in school. All right, we're just taking all of that, digesting it, and putting it together. All right, so that's the purpose of going through this whole exercise.